algebraic identity is an algebraic equation that is valid for any value of its variable. Let's take one example: x plus y whole square x square plus 2xy plus y square. It is an algebraic identity because if we put any value of x and y, it generates the same value both left side and right side. But if we consider another algebraic equation, that is one example, x plus 2 whole square is equal to 9. This algebraic equation is valid for the x is equal to 1. For any other value of x, it is not satisfied. So it is not a algebraic identity. These algebraic identity are widely used to solve algebraic equation, polynomials, and factorization of the polynomial, and algebraic expression to simplify the given equation or expression. So you should remember all algebraic identities going to discuss here, and here also you learn how to remember and few derivation also. Now we make list the algebraic identities of similar group. First we consider a plus b whole square. So to write a square plus 2ab plus b square, and this also further you can write a minus b whole square plus 4ab. This part you can derive. Next is a minus b whole square, a square minus 2ab plus b square. Also you can write as a plus b whole square minus 4ab. Both this part you can derive because a minus b whole square plus 4ab can simplify it, a square minus 2ab plus b square plus 4ab is equal to a square plus 2ab plus b square. So it is similar the middle expression, or from here also you can write as a plus b whole square. Only you have to remember this part, and this part you can remember with the derivation. Next is a plus b whole cube, that is a cube plus 3a square b plus 3ab square plus b cube. Further you can write as a cube plus b cube a cube plus b cube plus 3ab into a plus b. This part you can derive it from here, and look at this, a cube plus b cube, and if you take 3ab common here, the remainder is a plus b. Next is a minus b whole cube, will be a cube minus 3a square b plus 3ab square minus b cube. So it is consecutive plus minus, and further you can write as a cube minus b cube minus 3ab, you take common here, what remain a minus b. So now you can see that all are minus, here all are plus, but this part you can remember with the derivation, but this part you have to remember. Next also you can write a plus b whole to the power 4, or a minus b whole to the power 4, or you can write as a plus b whole to the power 5, or a minus b whole to the power 5, and so on. And for this you should have some knowledge about the binomial theorem. What binomial theorem say? Let's take one example, a plus b, it is a binomial because there are two terms, and if we take one exponent or the power, that is n, the binomial theorem help us to expand this expression. How you can do that? First you have to write a to the power n, next is nc1 and a to the power n minus 1 p. Look at this, here a to the power n and power reduced by 1, and here power was b to the power 0 and increased by 1 and become b. So every time in the consecutive term, each variable, mean the first variable power decrease and the second variable power increase, and we continue. And here this nc1 binomial coefficient, so we can write the other term as nc2 a to the power n minus 2 into this, or the multiplication relation, to b to the power 2 or b square. Then is nc3 a to the power n minus 3 and b cube, plus write the general term r plus 1th term, that is ncr a to the power n minus r and b to the power r. This way we can continue, and last we get b to the power n. Now how we can get this binomial coefficient value? We can derive it. Let's take the example ncr. We can write factorial n by factorial n minus r factorial r. Let's take one example. If it is 3c2, then we can write as factorial 3 by factorial 3 minus 2 and factorial 2. And further we can simplify. Factorial 3 by 3 minus 2 is factorial 1, and here is factorial 2. And numerator we can write as 3 into factorial 2, and here it is factorial 1 into factorial 2. So this factorial 2 cancel out and 3 remain. So 3c2 value is 3. But this all binomial coefficient we can get it by simple Pascal's triangle. Let's write the Pascal triangle. The top we put 1, next row is 1 and 1, next row is 1, and we add the 2 1, that is 2, and here it is 1 both end, and both end 1. Then we add the top row value, first and second value, that is 1 plus 2 is 3 and 2 plus 1 is 3, and end also 1. Then it is 1, 3 plus 1 4, and 3 plus 3 6, and 3 plus 1 4, and again it is 1. Next is 1 5, and 4 plus 6 10, 4 plus 6 10, then 4 plus 1 5, and that is 1. And how we can apply this Pascal triangle? So when the n, here the power or exponent n is 0 and it is 1, and for the third row it is 2, and for the fourth row it is 3, and it is 4 and 5, and it will continue. So let's apply this Pascal triangle on some algebraic identities, that is a plus b whole cube. It is similar as the binomial expression, that is a plus b to the power n when n is 3. So we apply this part, fourth row. So these are the consecutive binomial coefficient. So we can write all coefficient. So we can write first all coefficient, that is 1, and here it is 3, and next is 3, and last one is 1 cube, and b0, then it is a square and b, next is a b square. And look at this, every time the consecutive terms, the first variable power reduced by 1 and second variable power increased by 1, and last one is 1 into b cube. So finally we get a cube plus 3a square b plus 3ab square plus b cube. This is the simple derivation. Now easily we can find out a plus b to the power 4. For that we follow this row, this fifth row. So we can write as a to the power 4, and next is 4 a cube b plus 6 a square b square plus 4 a b cube, and next is plus this b to the power 4. Clear? Same way we can write the a plus b to the power 5 algebraic identities. It will be a to the power 5 plus 5 a to the power 4 b plus 10 a cube b square plus 10 a square b cube plus 5 a to the power 4 plus b to the power 5. Next we learn a square plus b square, then write as a plus b whole square minus 2ab, or we can write as a minus b whole square plus 2ab. From where we get this value? A plus b whole square minus 2ab. We expand this first algebraic identities, that is a plus b whole square, we can write as a square plus 2ab plus b square minus 2ab. So we get a square plus b square. Next is a square minus b square, is you can write as a plus b into a minus b. Next is a plus b plus c whole square, you can write as a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Next is a cube plus b cube, you can write as a plus b a square minus ab plus b square. Here you must remember, when the power is odd of this both term, then the one factor is a plus b. Here means if it is a to the power 5 plus b to the power 5, or a to the power 5 plus b to the power 5, there is a factor of a plus b, consider quotient. A plus b whole cube minus 3ab into a plus b. Now how you can remember? Now look at this. If you expand the a plus b whole cube 3ab into a plus b, you get a cube plus b cube 3ab into a plus b and minus 3ab into a plus b. Next algebraic identity is a cube minus b cube. You can write as a minus b a square plus ab plus b square, because for a cube minus b cube, since this power value is, since for a cube minus b cube, since the power is odd for the both terms, so there is a factor a minus b, and this is the quotient part. Further we can write as a minus b whole cube, because if we expand the algebraic identity a minus b whole cube, we can get a cube minus b cube. That is the reason we write a minus b whole cube plus 3ab into a minus b, a to the power 5 minus b to the power 5, and since both power is odd, so there is a factor of a minus, and the quotient will be a to the power 4 plus a cube b plus a square b square plus ab cube plus b to the power 4. And next is a cube plus b cube plus c cube minus 3abc. This is very important algebraic identity. We can write as a plus b plus c, a square plus b square plus c square minus ab minus bc minus ca. Further, we can write as, if we multiply with 2 of this second factor, we get a plus b plus c, 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. And if we rearrange it, we get a minus b whole square plus b minus c whole square plus c minus a whole square. A plus b plus c into a plus b plus c whole square minus 3ab plus bc plus ca. And last but not the least is a plus b plus c whole cube is equal to a cube plus b cube plus c cube plus 3a plus b plus b plus c plus c plus a. Almost we cover all important algebraic identities. Thank you very much for watching this video.